Alright, so today's video is called Exploring Linear Parameter Changes. So that's a big fancy word for basically just saying we're going to change different parts of the equation. So we're dealing with just lines. So if we change the slope, what's going to happen? What happens when we change the y-intercept? So to start with, in order to see how something is changing, we need to have a base point. So something that we are comparing all of our new lines to. And that base point that we're going to use is the parent function for a line. So basically the parent function just means the most basic function. It's where all the other lines originate from. Just like you originate from your parents, right? So you have some of the same characteristics as your parents, but you might have blue eyes instead of black eyes. So some little things might be off, but you have a lot of the same genes from your parents. So you originate from them. So we're going to find out how do all of these other lines originate from our parent function, which is f of x equals x. That is the most basic line that we can have. And so remember, f of x is just another name for y. So that's basically just the equation y equals x. So looking at that equation, I want you to identify the slope. So remember, the slope is this number that is in front of x. So what number is in front of x in the parent function? It is a 1. So the slope of the parent function is 1, and the y-intercept is the number that comes at the end. So the y-intercept, there's nothing being added on to the end, so it's really like plus 0, so our y-intercept is 0. Alright, so now what we're going to do is we're going to kind of go through some steps and explore to find out what happens if we change certain things. How does that affect the line? That way we don't have to graph it every time. We can tell just by looking at the equation how it's going to change. So first thing you're going to do is type the parent function into y equals on your calculator. So grab your calculator, go to y equals, and our parent function again is right here. It's just f of x equals x. So this is the most basic line that we can have. So in y equals, you're just basically typing in x. So now go to your table, and we're just going to fill in just 3 points from that table to help us graph an accurate line. So looking at your table where x is -4, the y value there is -4. So I'm going to plot that point. 1, 2, 3, 4, 1, 2, 3, 4. That is that point right there. The next point, I'm looking at where x is 0, and on our table that shows a y value of 0. So 0, 0 is that origin right in the middle. And then the last point, I'm looking at where x is 4. So when x is 4, the y value is also 4. So I'm going to plot that one. There we go. And now we are going to use a ruler. Please use a ruler to make sure your line is straight. We're going to use a ruler to draw that line. And remember to put arrows on the end because it is not stopping there. Alright, so now we have that labeled, or we need to label it so we remember which one that is. And I'm going to highlight my lines just because I want to be able to see them later. So f of x up there, I highlighted that in yellow. I'm going to highlight that in yellow. Alright, so that's our parent function. So every time I'm asking a question, I'm going to relate it back to that yellow line. Alright, so the first change that we're going to make is we're going to add 3 to the parent function. So remember, this right here, this was the parent function, f of x. And so we're going to add 3 to that. So f of x, we said in the parent function, f of x is just x. So if two things are equivalent, we can interchange them, right? So instead of writing f of x again, we can just write x because f of x equals x. So now we have our new equation. I'm going to use a different color highlighter for this equation. Looks like I'm going to use blue. And the equation this time is g of x equals x plus 3. So just real quickly, let's go ahead and identify our slope. So the number in front of x is a 1, and our y-intercept is 0. So again, I'm going to go to y equals, I'm going to type in my new equation, which is x plus 3. I'm going to write down the points from that to help me graph. So when x is -4, we have -1. When x is 0, the y value is 3, and when x is 4, the y value is 7. So I'm going to go ahead and graph those. So there's -4, -1, 0, 3, and 4, 7. So I've got those points right there. I'm going to grab a ruler and draw the line. That ruler's not real good. Alright, so now I'm going to label that one, or I'm going to highlight it with blue so I remember that that is that g of x. Okay, and it actually doesn't hurt to label it too if you want to label that that's g of x. And then our first one was f of x. Alright, so now there's a question. How did the parent function move to make the new line? So what happened to our yellow highlighted line to get to the blue line? Like, how can we move the yellow line to get to the blue line? It is moving up 3. Oops, that's a highlighter. So it moved up 3 units. And you can tell if you want to look at each point, like from this point right here, it went up 1, 2, 3. This point went up 1, 2, 3. This point 1, 2, 3. And we could do that with any point on the line. We just had graphed 3 to make the line. So it moved up 3. Alright, so now this time we're going to subtract 4 from the parent function. So again, here's our parent function, f of x. So we're subtracting 4 from that parent function. And our parent function, f of x equals x. So we can replace f of x with x. And now we are going to, so I'm just going to highlight this so you remember that's the same thing. Those are just part of the parent function. So let's identify our slope. So the slope is 1 again, and the y-intercept is now -4. Remember that -4, we treat that as a negative. So I am going to use purple this time. So I'm going to highlight here. Alright, so I've got p of x equals x minus 4, and I need to go to my table. So type in to y equals x minus 4, go to your table, and we're going to get these points. So that's going to be -8, and we're going to have 0, -4, and 4, 0. So if I'm going to plot these points, -4, -8 is right there. 0, -4 is right there, and 4, 0 is right there. So again, grab your ruler, and we're going to draw that line. Put arrows on the end because the line's not stopping, and this line is p of x. And I'm going to highlight it as well, just in case you're writing with your pencil. Make sure you highlight so you can compare these graphs in a little bit. All right. So now the question down here, how did the parent function move to make the new line? So from the yellow line to the purple line, how do we get to that purple line? We're going to move down 4 units. Each point this time went down 4. So you can look at this one, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So each time every point was moving down 4. So that whole line was shifted down 4 units. Alright, so now I want you to compare the 3 different graphs. Alright, so the yellow graph, the blue graph, and the purple graph. What stayed the same in all of those equations? So just looking at the equations, so just identify M and B. Which one stayed the same, the M or the B? Only one of them stayed the same. So I'm going to label right here. We already did it up there, but M was 1 and B was 0. So every time the slope, which is our M, stayed the same, and what changed every time, all that we changed in all of these equations, was the y-intercept, or our B value. So therefore, changing the blank moves the parent function of a line up or down. That's going to be our y y-intercept. When we change the y-intercept, it's going to move our line either up or down. So if it is plus a number, that's going to move it up. If it is minus a number, that's going to move it down. All right, so if you start with your parent function f of x and we move it, or we add to it, that's going to move it up. If we subtract from it, that's going to move it down. All right, so now let's look at what happens when we change the m, which is our slope. So we're going to start with our parent function again, because remember, we always want to have a baseline to compare to. So from our parent function, our slope is 1, the y-intercept is 0, and we get these points, -4, -4, 0, 0, 4, 4, there's 0, 0, -4, -4, and 4, 4. Draw my line. And I'm going to highlight that in yellow. All right, so there's my parent function. So now the changes that we're going to make is we're going to be multiplying instead of adding or subtracting. So this first change, we're going to multiply the parent function by 2. So I'm going to use blue. We're going to multiply the parent function by 2. So remember, f of x right here, we can replace that with x, because f of x is our parent function, and it says that f of x equals, oops, that's not a highlighter. It says f of x equals x. So we're just taking f of x out and putting x in its place. So now we're going to fill in this table. So -4, when you go to y equals, you're typing in 2x. And when you look at your table, when x is -4, that's going to be -8. When x is 0, that'll be 0. And when x is 4, it's going to be a +8. So let's plot these points. -4, -8 is going to be right here. 0, 0, right there. And 4, 8 is going to be up here. So we see a little bit of a different change here. Arrows on the end, and I'm going to label this one as g of x. My first one I should have labeled as f of x. All right, so again, especially if you just have pencil, make sure you are highlighting. If you're using colored pens, you can just color code your lines. All right, so now one thing we forgot to do is identify our m and b. So the slope in this equation is 2. The y-intercept in this equation is 0, right? Because we're not adding anything on there. There's nothing being added. So which line is steeper is the question. Is it the parent function, which is f of x, or is it g of x, our new line? Which one is a steeper line? Well, the blue line. Remember, steeper means it's going up at a faster rate. So think of a steep hill, which these were hills, which one would be steeper? So g of x is definitely steeper. All right, so keep that in mind. And now let's look at another one. Let's see what happens when we multiply the parent function by 1/4. So replace f of x with x. So go to y equals. We're going to type in 1/4 x and fill in our table. All right, so this, if you type that in, when x is -4, y is going to be a -1, 0, 0, and 4, +1. So let's identify our slope real quick in our y-intercept from our equation. So the slope is 1/4, the y-intercept is 0. All right, I'm going to use purple highlighter this time. So p of x equals 1/4 x. And we're going to graph this line. So plotting these points, I've got the point -4, -1, 0, 0, and then 4, +1. So take your ruler, draw your line, go ahead and draw it from edge to edge of that graph. All right, so now let's see. The question says which line is steeper, the parent function, f of x, or our new line, p of x. So basically, is the yellow line steeper or is the purple line steeper? Well, the yellow one, right, which is f of x. So our parent function was actually steeper. Parent function, which was f of x, right? So this one is p of x. All right, so what do you notice about the slopes? So the first one, our parent function, the slope was 1. The next time it was 2, and then it was 1/4. And our y-intercepts, the first one was 0, the second one was 0, and the third one was 0. So what stayed the same? The b value this time stayed the same, and the slope, the m, is what changed. So changing the slope, how does that affect the line? That makes it either steeper or less steep. And so if the m value, if your slope is greater than 1, then it's going to be steeper. If it's less than 1, then it's going to be less steep. And we'll talk a little bit more about that in a second. But now let's look at number 6 here. It says, what if we multiply the parent function by a negative? That symbol right there is a negative symbol. So we have n of x equals negative times f of x. So f of x, our parent function, I'm going to replace the f of x with an x. So into y equals, we're typing in just negative x. And I'm going to highlight this one. We'll use pink this time. All right, so m is a -1. B is 0, right? That's like adding 0 on, just like we were doing up here. All right, so let's get our points. Then when x is -4, y is going to be positive 4. When x is 0, the y is going to be 0. When x is 4, it'll be -4. So let's plot these points and see if we can see the difference. All right, so -4, +4, 0, 0, and 4, -4. All right, there's our line, and this is n of x. All right, so the most obvious change you can tell is when we multiply by a negative, when we put a negative out there in front of the function, what does that make the line do? It goes in a blank direction now. It goes in the opposite direction. So you can see the first 3 lines that we graphed all went up from left to right. And this, now when we added it to make it a negative, now it's going down from left to right. So that is what's going to happen when you have a negative. All right, so we've put together a little quick reference chart. So just remember, this is your parent function. So anytime you have f of x, you can replace it with x. So the biggest changes, and I'm going to use the colored pen that we used for b here. When we added b or subtracted b, so basically if we added a number after or if we subtracted a number, that's changing the y-intercept, right? So both of these, that's changing the y-intercept. So if we add or subtract the y-intercept, adding it makes it move up, subtracting it makes it move down. Then if we change the slope, that was our m value, right? That's the number in front of it. So if we multiply the function by m, it's either going to make it steeper or less steep. Now I want to talk about these bars that are around the m right here. These bars stand for absolute value, and the reason we have that is because the negative, if we have a negative number, we learned on that last example that all that really does is make it change direction. So even if you have a slope of, let's say our slope was -3, the absolute value of -3, absolute value is just the positive of the number. Okay, so the absolute value of -3 is really just 3. So that means it would be steeper. The negative just means that it's going to make it go down. So you want to look at just the positive value of the slope to decide if it's going to be steeper or less steep. So if that absolute value is greater than 1, then it's going to be steeper. If the absolute value of the slope is less than 1, then it's going to be less steep. And then finally, we talked about this negative. If we have a negative out in front, all that's going to do is make it change direction. So now our line will be going down if it is negative. Okay? So we have a couple examples down here. Use this chart to help. It really makes a huge difference, and we'll get to some quadratics later in the year that we'll use a similar chart for, and it's the same type of changes, the same type of transformations. So starting with our parent function, that's always what we're going to compare to. I want to know what happens when I take this parent function right here. So example 1 is q of x equals f of x minus 2. So I'm taking the parent function and I'm subtracting 2. So looking at these 4 or 5 different examples up here in this chart, which one does that look like? Well, this is what's changing. So it's just like we are doing this one, right? We're subtracting a b value. So if we're subtracting 2, that tells us that we are going to move the graph down 2 units. All right. So now the next example, there's 2 changes. The first change that I see is I don't have a positive f of x, I have a negative. So the first thing is we know it's going to change directions. And then the plus 1 at the end of it, that's changing the b value, so that means it's going to move. If we're adding the b value, that moves it up. So move up 1 unit. So 2 things were happening, right? The line changed directions and it moved up 1 unit on the y-axis. Example 3, h of x. So let's look and see. The first difference I see is in front of f of x, I'm multiplying it by 1/3. So is this line going to be steeper or less steep than the parent function? It's going to be less steep and by 1/3. So it's going to be 1/3 as steep. Or let's change the wording. Let's say 1/3 less steep. So it's going to be 1/3 less steep than the parent function. That's the only thing that happened on that one. So the next one, though, we have 2 things again. So first thing I notice is there's a 2 out in front, so it's going to be 2 times as steep, or 2 times steeper. 2 times steeper. And then the minus 5 at the end, that's changing our b values. That means we're going to move down, since it's minus, down 5 units. All right, so there's a couple examples for you if you're looking at the equations. So now I'm going to look at 3 different functions, f of x, g of x, and h of x, and we're going to determine which one is highest on the y-axis down to the lowest. So that means that we're moving up and down. So if we're moving up and down, if we're talking about the y-axis, what do we need to look at? The m or the b? Which one moves the graph up or down? The b value. So I'm gonna outline, box the b value on each one. Now this first one, there's nothing added on, so that's like a 0, right? So we have 0. This one's a -1, and this one's 5. So if I want to know which one is the highest, I want to start with the biggest number, because that's going to be our y-intercept. That's where we start the graph. So we want to know the highest on the y-axis. Well, that's going to be the one with the 5. So our highest graph is going to be h of x, which equals 1/3 x plus 5. Okay, that's a 1. The next highest graph, so we've got rid of this one. So now between 0 and -1, which number is bigger? 0 is bigger, so that's going to be the next highest one. So f of x is going to be the next graph. And you can go ahead and put plus 0 or just leave it as x. And that leaves finally the lowest one on the y-axis will be 2x minus 1, which is g of x. All right, so we've knocked all those out. So those are the highest on the y-axis down to the lowest. You could graph those in your calculator just to verify that if you wanted to. And then finally, we're going to list the equations in order from steepest to least steep. So the steepest would be like if you were going up a hill, this one is going to be going up at the fastest rate. So if we're looking at steepness, we want to look at the slope. So let's look here. The slope of this first one is 1. The next one, the number in front of x is 2. And then on h of x, the slope is 1/3. When I have a fraction, I always like to figure out what that is as a decimal. So if I type in 1 divided by 3, I see that that is really 0.3 repeating. So I have a slope of 1, 2, and 0.3 repeating. So if we want to know the steepest one, I'm looking for the biggest slope. So what number is the biggest? Well, 2 is. So this graph is going to be the steepest. All right, so we've taken care of that one. The next steepest, the next biggest number is 1. So that's going to be the next steepest. So f of x equals x, which is our parent function. And then the least steep is going to be the h of x, which is 1/3 x plus 5. All right, so changing the y-intercept moves the graph up and down. That's if you're adding a number onto the end of the parent function. Multiplying the slope is going to change the steepness. So if it's greater than 1, it's going to be steeper. Less than 1 is going to be less steep. And then finally, if we have a negative, all that tells you is that it changes direction.